Okay, today we're going to take a look at 4-4 Cpctc. Cpctc, what we're trying to do is find information about congruent triangles. This is a continuation of what we've been doing so far in this unit. In 4.1 we talked about congruent shapes, and then we moved on to the 5 shortcut methods to prove that triangles are congruent, so side, 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 angle, side, angle, side, angle, 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 side, and HL. So you might be asking, well, what is Cpctc? Cpctc stands for corresponding parts of congruent triangles are congruent. What this means is that from 4.1 we said that if we have congruent shapes, then we can say that these parts match up, they're corresponding with each other, so these angles match up, or sides match up. And if we're able to prove triangles are congruent using one of our 5 methods, side, 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 angle, side, angle, or HL, we can then use Cpctc to basically pluck parts of information from one triangle to the other, because we know that they are going to be congruent and corresponding parts would match up. This may also be called Cpctc. I will generally stick with Cpctc, but on our assignments sometimes you might have Cpctac. So just be aware that they're exactly the same. So now, the way that we go about doing this is that in most cases we're dealing with proofs, but these are going to be fairly simple proofs. The idea is that they can fill it out as a 2-column proof. So, we have our 2-column proof form, and we'll start with our given information. So we know that angle N is congruent to angle P. That is a given. We also have that angle M is going to be congruent to angle Q, which is also given. And then we also are given that MO, segment MO, is congruent to segment QR. So also a given. So to be able to apply Cpctc, I need to state that these triangles are congruent to each other. So when we look at this diagram, I'm trying to figure out, are these triangles congruent to each other? Well, I have 2 angles and I have a side. The side is non-included. So because the side is non-included, this is angle, angle, side, along with angle, angle, side. So I can say that triangle, and this is very important because the way I'm going to label it matters, NMO is congruent to triangle. And because I said NMO, I need to go 1 to 2 to 0. So I'm going to go 1 to 2 to 0. So that would be PQR. And the reason that I know that NMO matches with PQR is because of angle, angle, side. So I'm trying to prove that O is congruent to R. Well, because I've now been able to say that NMO is congruent to PQR, well, O and R are corresponding. They are in the same location. They go with each other. So that means that angle O is congruent to angle R by Cpctc. So really all we're doing is we're proving that we have congruent triangles using the stuff that we've already been doing in 4.2 through 4.3. And then we're just throwing on one extra line and we're saying, well, now I know that the triangles are congruent. And because they're congruent, this has to match up with that. And that is Cpctc. So here's another one. I'm not going to fill out a full proof for this one, just to kind of save us a little bit of time here. But the idea is that I yet again have 2 triangles. And what I want to do is I want to try and prove that these are congruent to each other. If I can prove they're congruent, then I can try and match these 2 angles up with each other as long as they are corresponding. So we have 2 sides. Well, we also have an angle because we have this angle. So angle CAB is congruent to angle EAD. Well, why is EAD congruent to CAD? And those are just vertical angles. And we know that vertical angles are always going to be congruent to each other. So that gives us the angle that we're looking for. And now I have that these two triangles CAB. So triangle CAB would be congruent to triangle EAD. The reason I know that CAB and EAD are congruent to each other is I have two sides and an angle, and this is an included angle. So this is going to be side, angle, side. And then now that I've been able to prove that these triangles are congruent, corresponding parts go together. Well, C and E go together. So angle C is congruent to angle E. And we use Cpctc. Ta-da. So here's another example. I don't know if this is true, but apparently one of Napoleon's officers used congruent triangles to estimate the distance across a river to basically get to a combat site. And this is something that you could actually easily apply. So you have these two triangles, and you're trying to prove that they are congruent to each other. If they're congruent, then you can easily match up the sides to find the distance across the water. So let's say we have two right triangles. So I'll just go ahead and diagram these out to make it a little bit easier. So we have two right triangles, it says. We have DEG and DEF are going to be right triangles. So we'll say DEG. And then D, E, and actually I should probably put this as E to try and match up exactly what they have in our diagram up above. So we have D, E, G, and D, E, F. And it says that EDG, so EDG and EDF are going to be congruent to each other. So we also have DE is going to be congruent to DE, because we can see in our diagram that DE is a shared side, and shared sides are always congruent. So the officer then paced off the distance to this spot and declared that distance to be the width of the river, used congruent triangles to prove. So what they did was that they looked from here, and then they turned and looked at this side of the river, and using the brim of their hat, they got the same distance. So actually, we also have this EF and this EG should be the same distance, because they were able to use their hat to keep a measured distance and then look between the sides. So I know that this is congruent to that. Well, I have a right triangle in which I have a short side and the hypotenuse. So then therefore these two triangles are congruent. So triangle DEF is congruent to triangle DEG. Why is this congruent? Of course, this would be HL. So that covers our triangle congruence. Well, now that I know that the triangles are congruent, I want to prove EF and EG go together. Well, EF and EG are the last two letters, which means they are corresponding. So we know that EF is congruent to EG because of Cpctc. So that's pretty much what we're doing with Cpctc. You need to prove that your triangles are congruent using one of the 5 methods that we've covered. Once you have that, you're good to go. As long as the parts are corresponding, Cpctc allows you to state that things match up. So that covers our notes for Cpctc. It's pretty straightforward and not super difficult.